Hi, everyone. I'm Mariah Yeager, and I'd like to thank you all for joining us for our SMA speaker session today. It's entitled Challenges and Opportunities of Advances in Satellite Technologies and National Security Perspective. I'd also like to thank today's speakers, Dr. Lawrence Rubin, Dr. Mariel Borowitz, Major Brian Stewart, and Dr. Glenn Lightsey for taking the time to present today. Before we begin, I have a few quick housekeeping items. We'll be having the Q&A session at the end of the brief. So throughout the brief and even during the Q&A, please feel free to submit your questions via the live event Q&A chat. Just click the chat icon, which is two overlapping speech bubbles with the question mark. And please be sure to type in your name and affiliation with your question. But if you prefer your name to not be recorded, you can submit your question anonymously. Please also vote for the questions that you'd like most answered by hitting the like message to each question. And you could do this throughout the Q&A as well. So now I'd like to turn the floor over to our moderator, Dr. Lawrence Rubin, to get us going. So Dr. Rubin, over to you.
Thank you very much. Thanks for your patience, first of all. But secondly, thanks for the introduction and to SMA for this opportunity. And of course, to the audience for its precious time. I'm Larry Rubin. I'm an associate professor in the Sam Nunn School of International Affairs, Georgia Institute of Technology, and I have this great honor of being today's moderator for this event titled Challenges and Opportunities of Advances in Satellite Technologies, a National Security Perspective. Our esteemed panelists will examine the national security implications of advances in satellite rendezvous and proximity operations on orbit, servicing technologies, and the proliferation of small satellites. These advanced and advancing technologies continue to provide challenges and opportunities for actors in the government and commercial sectors who have the capabilities and those who seek capabilities to acquire them. Today's panelists will address a few key questions from their specific areas of expertise. These include, are the dual use nature of these technologies and a lack of governing rules of behavior an opportunity for technological innovation or a threat to security? Given the increasing number of capabilities of objects in space, how do we ensure a space environment that's safe and sustainable? What technological solutions might be offered, and where do policy and international relations play a role here? And third, what are the national security implications of these solutions? So more broadly, these important questions we must consider in the context of the reemergence of great power competition and the increasing number of state and non-state actors in space. The potential instability caused by these emerging technologies could have profound effects on global peace and security, as we know. This discussion, in fact, builds on a recent article that two of our panelists, Dr. Mariel Borowitz and Brian Stewart, Major Brian Stewart, as well as your moderator here, co-authored entitled Emerging Satellite Technology and National Security. And should be a link, and if you have any problems accessing this as part of the background, then feel free to get in touch with any of the panelists. I also want to say that this panel will go beyond this article and looks more into some of these ideas a bit further, and to combine this space policy perspective and national security perspective, and as we have a technological or technology perspective on this provided by Professor Glenn Lightsey. In other words, this panel is going to bring together the science, technology, and policy angles to address these pressing issues. So to provide a quick overview and a space policy perspective on these important questions, we have Dr. Mariel Borowitz. Dr. Borowitz is an associate professor in the Sam Nunn School of International Affairs at Georgia Tech, and her research deals with international space policy issues, including international cooperation and Earth observing satellites and satellite data sharing policies, as well as strategy and developments in space security and space situational awareness. Dr. Borowitz earned her PhD in public policy at the University of Maryland, and master's degree from GW in international space technology policy, and a Bachelor of Science in Aerospace Engineering from MIT. Also, very importantly, Dr. Borowitz completed a detail as a policy analyst, the science mission director at NASA, headquarters in DC, from 2016 to 2018. And she has an important book called Open Space, the Global Effort for Open Access to Environmental Satellite Data. It was published by MIT Press in 2017. And I mentioned these long bios important because, as I mentioned, one of the issues, the aspects of this discussion here is taking these different angles. So our second speaker, Major Brian Stewart, is going to focus his remarks on the national security implications of these issues. Brian Stewart's a major in the U.S. Space Force, completing a PhD in the Sam Nunn School of International Affairs. His research focuses on efforts, the effects of national security, space systems, entanglement, deterrence. And Major Stewart is an active duty in the Space Operations Officer with 12 years of operational experience, and across also through the intelligence community. He was also deployed in 2014 and through 2015 as a National Reconnaissance Officer liaison to Afghanistan. And following this degree, Major Stewart will return to the U.S. Air Force Academy, where he's going to join the faculty in the Military and Strategy Studies Department. And then our third speaker, Professor Glenn Lightsey, will share his thoughts from a technical perspective and go into a bit more depth onto where technology might provide challenges and opportunities. Dr. Lightsey is a David Lewis Professor of Space Systems Technology in the School of Aerospace Engineering at Georgia Tech. He's a director of the Space Systems Lab Design and director of the Center for Space Technology and Research. His research includes technology of small satellites and guidance and navigation control systems, unmanned space rendezvous, and a whole array of many technological aspects. It's also really interesting and important that Dr. Lightsey founded two companies which invents space technology. One of them was in fact acquired. So he's got a very good perspective on the commercial academic aspects of these. He's published prolifically, and I will end the esteemed introduction there. Last note, before I turn it over to Dr. Borowitz, please send your questions at any time, as many of you already have, and we'll try to get to as many of them as soon as possible, as many as possible. Dr. Borowitz, I'll turn it over to you now. Thanks so much.
Wonderful. Well, thank you so much, Dr. Rubin. Very happy to be here and speaking on this panel. So I'm going to provide a little bit of an intro just to the topic overall and some of the particular technologies that we focused on in the paper. And then, as Dr. Rubin said, I will address some of these key questions from kind of a policy and international affairs perspective. So before I go into the particular technologies we focus on, I just want to remind everyone, we have thousands of objects in space, operational satellites in space that provide a broad array of capabilities that are very important both on the economic side, globally, and particularly in the United States, and for the military as well, right? So reconnaissance, communications, positioning, and timing, all these many applications that we really rely very heavily on space assets. And there are a lot of well-known risks to these space assets. So risks that come from just the number of objects that are up there and the amount of debris that's there, so you can have accidental collisions, but also risks that stem from the potential for purposeful attacks on satellites. So with that as kind of a background to the environment, very quick background to the environment, some of the technologies that are advancing very rapidly that we're particularly interested in are small satellites. So the capability of these small satellites has really been increasing very rapidly over the last kind of 5 to 10 years. That means we can get a lot more actors involved in space. So this means a variety of different countries. I think I saw the statistic recently, it's getting close to 100 different countries that have some activity in space. And also it's created this opportunity to put more things in space more quickly. And so if you look at the number of objects in space, it is really just increasing very rapidly. And we're just starting on this new age of what we're referring to as mega constellations. So, we've in the past had constellations of a handful of satellites, even kind of tens of satellites. And now we're talking constellations of hundreds to thousands of small satellites, which really changes the calculus in terms of the possibilities for collision and other issues there. There are other technologies, and two of the ones I want to focus on are remote proximity operations and on-orbit servicing, which are closely related and which Dr. Rubin mentioned. So remote proximity operations, as it sounds like, is basically, spacecraft that are able to get very close to other spacecraft. This is not something you normally want to do. Usually if you get within, maybe a kilometer or even less of another satellite, you're going to get a warning from Space Command that you have a possibility of a collision or a conjunction. So when you're able to get within, tens of meters or even less, it's something unique. But it's something that, the capability to do that has really been increasing in recent years. So militaries have been able to do it for quite a while, but now we're seeing on the commercial side as well. When you're getting that close to other satellites, you might do things like take images. That can be useful for identifying debris, right? One of the problems I mentioned earlier. It can be good for diagnosing issues with the satellite that is malfunctioning, maybe planning repairs. And of course, it can also be useful for reconnaissance if you're taking a picture of someone else's satellite. This ability to get close to other satellites is also a key capability for co-orbital anti-satellite technology, right? So if you want to destroy someone else's satellite, you need to be able to rendezvous with it. So as I mentioned, it's been around for quite a while. The military has had this capability in the US and elsewhere. The space shuttle is able to rendezvous with satellites. So even, on the civil side, we've had that capability. But now we're seeing more activity in this area. So in particular, Russia and China in the last 5 years or so have had satellites that are moving around and rendezvousing with other satellites. On the Chinese side, it's mostly been getting close to their own satellites. But on the Russian side, they actually have gotten very close to commercial satellites owned by US and other companies, a French satellite, a US reconnaissance satellite. So they are not limiting it to a rendezvous with their own satellites. On-orbit servicing is really an extension of the capability to do rendezvous and proximity operations. So you're not only going to get close, now you're also going to actually grapple that satellite, work with that satellite, and ideally repair that satellite or extend the mission somehow. This is a particular interest in the commercial sector. There actually was a launch already. Northrop Grumman put up Mission Extension Vehicle 1, which is the first kind of operational commercial on-orbit servicing spacecraft. And so with this capability, as you can imagine, they're using it to grab onto another satellite and basically provide additional fuel that's going to let that satellite operate for a longer period of time. Very valuable when you don't have to then pay for a whole nother launch, pay for a whole nother satellite. You can keep what you have. But if you have the capability to move closely and grab onto someone else's satellite, you can imagine you can also do a lot of damage instead of doing repairs. So then looking to the questions that Dr. Rubin posed, are the dual use nature of these technologies and the lack of governing rules of behavior an opportunity for innovation or a threat to security? So as you can imagine, of course, it's both. The dual use nature of these technologies does pose a challenge. It's impossible to know for sure, just looking at the capabilities, how that satellite or how that spacecraft is going to be used, what the intent is behind it. And that intent could change over time, right? Something that was built for commercial purposes could potentially be hijacked or have a change. On the same time, we don't want to ignore the opportunities there, the capabilities of rendezvous and proximity operations and of on-orbit servicing in particular could be a big commercial market. They could really help us improve the efficiency and effectiveness of the objects that we have in space right now. If they're used for debris removal, they can help with issues of, that we have with potential collisions with debris. So there are a lot of opportunities that we want to make sure we're engaging with these technologies. But there are dangers as well, as I mentioned. Not surprisingly, from a policy and international affairs perspective, I would say that those elements are going to have a big role to play in the solution. So the lack of rules of behavior really is a problem that we need to address. There's a scholar named Ruth Stilwell who says there's without good rules, there are no good actors, right? So we have to define what acceptable and unacceptable behavior are on the international level in order to start addressing these issues and trying to enforce those norms of behavior. And we've seen the importance of this already. I mentioned Russia having some spacecraft coming very close to US spacecraft and to commercial spacecraft, when complaints have been made about those activities, to the extent that Russia does respond, their response has been something to the effect of, there's no rule against what we're doing, right? There's nothing wrong with what we're doing. We're just, experimenting in space. And so getting on the same page about what's acceptable, what's not, how close can you get to another satellite is really a key aspect that we need to do on the policy and international relations side. The other questions that Dr. Rubin posed asked about, how do we keep the space environment safe and sustainable, and where are there technology solutions versus policy and international relations solutions? So I'm going to leave the technology solutions to some of the other panelists, and there's some really interesting opportunities out there that they will speak to. But certainly, national policy and international engagement is going to have to be a solution, a part of the solution as well. This is not something, these are not problems that you can solve with technology alone. So we've already made progress on the international arena in terms of debris mitigation guidelines. So coming up with ideas that we can all agree with of how you can minimize the amount of debris that gets up into space in the first place. But that's kind of been the limit of where we've been able to find agreement. And there hasn't been a lot of progress even in that area in the last 10, even 20 years. And so we need to go further with that. Now that we have these small satellites, we have these mega constellations, there are analyses and reports that have come out that have said that, our current agreement that you have to deorbit your satellite within 25 years, that's not going to work anymore. Now we're talking about something like 5 years if we want to keep space a sustainable environment. We need to have better space situational awareness or space domain awareness data sharing. We need to have a better shared understanding of what's happening up in space. If we're going to have things like these rendezvous and proximity and on-orbit servicing satellites that have to maneuver in order to achieve their missions, we need to have some way of sharing that information about planned maneuvers, because a lot of our ability to project where we might have conjunctions or collisions is based on satellites traveling in predictable orbits. And if that's not the case, we need a way to incorporate that information. Looking at things like acceptable proximity, like I mentioned, how close can you get to someone else's satellite before it's considered irresponsible or threatening? Right now, there's no agreement on what that is, what that distance would be. We also don't have any agreement in terms of space traffic management. So meaning, if we have a case where two satellites are getting close to each other, or there's maybe a potential for a collision, Space Command is the one that will send out warnings to operators all over the world to let them know that that's happening. But beyond that point, there's no international agreement. So there's no requirement to move your satellite. There's no right-of-way rules in terms of who would have priority in moving. And so you're seeing things like NASA just signed an agreement with SpaceX, which is operating, putting up one of the first of these mega constellations, to work out the details between those two entities. What happens if a SpaceX satellite is going to potentially collide with a NASA satellite? But just doing these bilateral agreements on an operator-to-operator basis is not going to be sustainable in the long term, as we're talking about these hundreds and thousands of satellites going up. And so there's some work we need to do on a national level and on an international level to really get agreement in these areas. And there's some activity on this. So the UK last year went to the United Nations and proposed that we should have a UN level agreement on norms, rules, and principles of responsible behaviors. And the US is actively now drafting a US position on that they are hoping will become a mandatory set of guidelines. But it's not yet clear how specific this will be. So a lot of the international agreements that we have related to space right now are really quite general. And so it's hard to see what the impact is going to be and how effective they're going to be. So we'll have to wait and see in terms of that particular effort, how specific are the rules, and then are they able to start getting that international agreement. So I think I'll stop there and turn it over to the next panelists, and I'm happy to answer questions when we get to that stage.
All right, thank you, Dr. Borowitz. Thank you, Dr. Rubin. So I'm going to go into more of the specific threats from a national security perspective, and then I'll talk just briefly about some of the opportunities as well. So like Dr. Borowitz, I agree this is both a challenge, but also an opportunity. Specifically, I'm going to mostly focus on on-orbit servicing and rendezvous and proximity operations, but I'll mention small satellites briefly as well. For the first two of those groups, the major issue that threatens security is distinguishability. So these truly are dual use systems, both from the perspective of having both military and civilian uses, as well as from the perspective of being used for both peaceful and nefarious purposes. And unlike some other systems, there really is no technical way to distinguish these systems from being military or commercial or nefarious or peaceful, because they're inherently capable of both missions just by design. So it really comes down to intent, and intent is hard to figure out and can change over time. So the same technologies that allow you to drill into a fuel tank to replenish a satellite allow you to drill into a satellite to destroy it, and to grapple, same thing. So there's a lot of ways these systems can be used extremely effectively for a viable commercial market and a military market as well, but by design they're inherently capable of destruction. That leads me to the second point, is these systems will be used and operated in ways that we do not currently use and operate most of our systems. So while rendezvous and proximity operations do occur, they're on a very small scale. Dr. Borowitz mentioned the Russian satellite that everybody has been watching. Those are small numbers of systems that, you know, the highest level of spacefaring nations possess, and so they're much easier to monitor. When there's a proliferation of satellites that are maneuvering across orbital regimes, that becomes a much more significant challenge to maintain custody of all of these assets. And so, you know, these servicing systems and RPO systems will not just be used for a single satellite. To be commercially viable, they need to traverse across orbital regimes to get to their next target satellite. And so that frequent movement is not something that we currently do. Most of the time, satellites have to stay within, you know, a confined space. We do station keeping to keep it in its spot, and everybody knows where it is. There's a few satellites that move around frequently, but they're few in number. So having a massive number of satellites that are constantly moving across orbits creates a lot of different challenges. And then the fact that they'll be approaching satellites very closely and by design to be able to service them, you have a much higher risk of accidental collisions or debris being created as a result of collisions if these two spacecraft don't dock successfully. There's also issues with the capabilities of these systems beyond their intended design. So because these systems have to approach other satellites closely, they have very capable sensors on board, and these sensors allow them to collect intelligence as well. So in the past, the US has kind of maintained an advantage on what we call neighborhood watch, or being able to characterize the space environment to be able to determine what satellites are doing, what capabilities they might have, but that will be changing. There will be commercial providers who can image in great detail all of the satellites that are currently on orbit. When you think about, you know, National Reconnaissance Office satellites, who the image of which is classified secret TK, just, you know, the image of it, there will be high resolution images of these systems provided by commercial companies, and so that changes the way you might design these systems. So in the past, you were sort of able to hide in plain sight, but with much greater capability to collect from a lot of different actors. For instance, you can look at an antenna on a satellite and figure out what type of communications it's used for. You can look at receivers and see what type of intelligence it might collect. So you're going to have to employ different intelligence capabilities for those types of systems. And you also just have to be aware that there's really no way to hide in space anymore. These systems could also be used to test out US tactics and capabilities. So an adversary might not necessarily want to attack a system, but they might be very interested in how the US responds to close approaches. So an adversary might use these systems that are highly maneuverable and highly capable to regularly approach US satellites to see how we might respond, to see what tactics we might employ. They might also begin maneuvers to see how quickly the US notices the maneuver and updates orbital data. So there's a lot of ways that these systems can be used to test out tactics and capabilities of the United States. And so that presents a challenge for the US, is how do you kind of still conceal your capabilities while maintaining a response to things that are happening near your critical assets. Another issue is that since this is being developed primarily right now in a commercial market, we have very little control over the commercial market. That's a threat and an opportunity. So, the US does not want to impede commercial development in this area because it's very viable. But at the same time, commercial providers don't necessarily have the same level of encryption or protection on data that we might have on military satellites. And so there's an inherent risk of an adversary taking control potentially of a commercial spacecraft because the command and control links aren't as secure potentially. And then finally, I'll address just small satellites. So Dr. Borowitz mentioned there's hundreds and thousands of these satellites being launched. These are anywhere in size from a golf ball to a desk. So there are different categories: microsatellites, nanosatellites, all different types of small sats. But it really tests the limits of the US's ability to maintain space domain awareness. Some of these objects are so small that they're not easily tracked, and depending on the orbit, it's very, very difficult to maintain custody. The fact that this has for now been kind of a US-led effort is also an issue. Is it really US Space Command's job to let the world know of everything that's happening in space? The military isn't really resourced to let the European Space Agency know that a SpaceX satellite is getting close, or to let China know that a Nigerian satellite is getting close. But that's what's happening currently. So with more small satellites, that becomes a bigger challenge. And that's something that, is also an opportunity, because Space Command will not be capable of maintaining custody of everything on orbit. And so we will have to cooperate. And so that leads me to where I think the biggest room for opportunity is cooperation. So I think all of these threats present such a complex challenge that the only way out of this is not to engineer our way out of it, but it's to cooperate and to focus on policy solutions that can bring everybody together. So, we can partner on data sharing, as Dr. Borowitz mentioned. We can partner on norms. I think norms are one of the most critical, and I think most people agree on that. We can't call somebody's actions out as being hostile if there's no rule that they've violated. We can cooperate on other issues like debris removal. Last year at the International Astronautical Conference, some researchers presented a paper on the top 50 most dangerous objects in low Earth orbit. That if we remove some of these, there would be, orders of magnitude less threat to some of these systems. But there's no commercial market really to remove these 9,000 kilogram Russian rocket bodies, and Russia's certainly not going to pay hundreds of millions of dollars to do that. So we could come together internationally to work on solutions like that. For debris, that's a problem that's common and global to everybody who operates, and that will lead to greater cooperation in other areas as well. So there's a significant number of threats that I've gone over just briefly here. But I think all of these threats really provide the needed impetus for greater cooperation in space. And I hope that's the key takeaway, is that there really is a lot of opportunity here. So I'll turn it over to Dr. Lightsey now for his portion.
Great. Thanks, Brian. So hello, everyone. First of all, I want to say that who am I? I am just a professor at Georgia Tech. I feel like I'm the person out in the ether, who's kind of participating in this revolution of new satellites. I'm a user of the technology. I'm a developer of the technology. I'm an innovator, and I'm an enthusiast. Georgia Tech, as an institute, we're approaching 20 small satellites that we have designed and built or had some role in. We are just one university among many, and I think if you look globally, there are hundreds of people like me out there. So I think the genie is out of the bottle. I mean, inevitably, we have a lot more participation in space, commercial space, space science, and the capabilities of these satellites are getting better and better. As Dr. Borowitz mentioned, I'm working on a mission right now where we're proposing to fly 2 CubeSats 40 meters apart as a space telescope for space science. This is a capability that just didn't exist 10 years ago. And we can do something today for approximately $5 million that probably would have cost about $500 million 10 or 20 years ago. So this lowering of cost as the main barrier of access to space is really creating a lot more participation in space. And we see these IPOs coming out, like it seems like every week now there's an announcement of a new space IPO. So there's a lot of this happening. It's not going back to the way things used to be. Most of us want this. I think most of us feel, we're technology enthusiasts. We believe in a future where there is activity happening and participation in space and space exploration, and that it's improving quality of life on Earth. And, we don't want to go back. The alternative is to somehow wind the clock back. I don't think that's going to happen. So we have to learn to live with our own success and our own growth. I think that's, the important point is we are moving forward into a new domain. And what that means is that we really have to establish the rules of the road. I've often heard the space described as the Wild West, where like anything goes, and we can't continue to operate that way. And there is a huge international incentive for people to cooperate. Space is kind of a unifying theme. You go around the world, you talk to people, they're all very interested in space, regardless of their language or culture or political orientation. And there are analogies for these international cooperations, maritime and aerospace treaties and regulations. We've managed to do it in other domains. So we just have to do this in the space domain. I think we need to establish, first of all, some classifications. Are satellites maneuverable or non-maneuverable? We are seeing a lot more satellites that are maneuverable now, but of course, most satellites are non-maneuverable. So, knowing which satellites are which, having them declare their capability, I think would be very important. We need rules about space traffic density. How close can these satellites get to each other? We need guidelines for separation distances and relative velocities. It's really the relative velocity that matters as far as collision risk. And I can think of rules like no wake zones and things where as you get close to other satellites, you have to slow your relative velocity down. And of course, we need spectrum coordination. Some of that exists, but it definitely needs to be streamlined as we get more and more spacecraft into orbit. We need enforcement mechanisms, and I would argue that these mechanisms exist. This is one of the things people say, well, how do we enforce rules in space? The most obvious to me is access to space. So, it's not dealing with an immediate threat on orbit, but if you do have irresponsible actors, you can deny them access to space. And this is really done through launches. Launches, you must launch to get into space, and this is something that is easy to monitor. You can verify it and you can regulate it. So I think if people do not behave, if they're not good partners in the space domain, eventually they lose their access to space and they have to, rehabilitate themselves to get back into space. So those are the kinds of enforcement mechanisms we might have at our disposal. There also are things like spectrum, of course, management, and of course you can have fees and things like that. I think we have to think of space as an environment that has to be maintained. Up to now, space is, kind of like the side of the road. You can do whatever you want. You can throw your litter out the window. We can't think of it that way anymore. An analogy that I think of is as a national park. A national park, it looks like it's very scenic, but it's actually actively maintained by a park service, and the park service has a budget to maintain it. And we could have things like a use fee for people that are using space that goes into a service whose responsibility is to maintain the space environment for everyone. we can have rules like leave it as you found it, of course, being able to dispose of your satellite responsibly. I think electric propulsion, space tugs, this is a big capability, emerging capability in this area. Space as a service where you can contract with providers to dispose of your satellite after it's done with its useful lifetime. And as Major Stewart mentioned, identify the top 10 satellites that if you could dispose of them properly would greatly reduce the overall risk for everyone else. There are preferred orbits. So some orbits, if you can just reduce the traffic in those orbits, you would really greatly reduce the probability of collisions. So those are some things. I think technology, which is the area that I work in, has a big role to play in managing and monitoring space growth. It is enabling space growth, but at the same time, we can use it to manage space growth. We have to think of spacecraft in the future as active agents, not just passive satellites in orbit that are just kind of along for the ride, but especially maneuverable satellites as agents that work together on tasks cooperatively. We need to have autonomous collision avoidance at the vehicle, so the vehicle should be able to identify when it needs to make a maneuver autonomously and be able to do that to get out of the way, so it doesn't have to receive a directive from the ground through ground monitoring or whatever. Some of that is possible for nearby objects, but of course it's much more difficult for objects that maybe have conjunction events days or weeks in advance. So there needs to be monitoring and notification of collision risks, not just from the ground, but also from space. I would argue that there should be a space element of space situational awareness where you have spacecraft up there whose job is to sort of monitor the domain around them. Lots of technologies that have a role to play in this, like optical communications, of course, propulsion, satellite networking. These are all kind of emerging areas where there's rapid advances going on. So what needs to happen, I think, to transition to like a healthy, active space domain where people are kind of participating with confidence and, have their security is there needs to be international action. We can't just allow the status quo to continue because of the increased risk in the environment. There needs to be policy formation through treaties and committees that work together and really establish what these rules are going to be. And there need to be concrete goals, I think 10 and 20-year goals, just like we have with missile treaties. We have to have the number of vehicles or the certain capabilities in place in a certain amount of time, and then we need to take active steps to create those infrastructure systems. And that's really what this is about, is building an infrastructure in space that does not now exist. And that infrastructure really needs to engage monitoring, but also things like on-orbit servicing and repair. And then, of course, there need to be regulations for rules for people to follow, and there need to be enforcement mechanisms such as restricting access to launches for people that do not follow the rules, either through negligence or whatever. And I think that over time we can kind of evolve to a space domain that is very, has orders of magnitude more activity, but also is a secure environment where people can kind of operate with confidence. So I'll stop there, and I think we're ready to open the floor to questions.
Well, thank you. Thank you so much, all of the panelists, and particularly the end to give a very different and important perspective. You're very humble, Dr. Lightsey and Professor, in that way of really coming in and adding an important element to this conversation that's often missed. And what I wanted to do was, we have a number of great questions coming in, and I want to combine a couple first to start off. And the first two I'm going to combine are from Brian Meadows and director of SMA in this project here, Todd Veazey. And this question has to do with, first from Brian Meadows, and I'll try to direct it probably primarily to Dr. Borowitz and Major Stewart, but Professor Lightsey, feel free to chime in on these, especially if you have a particular angle here. Is China or Russia pushing these treaties that would give them pushing treaties that would give them an advantage should space military combat operations commence. Think here about the analog and the INF treaty that allowed China to develop long-range anti-ship missiles, while the U.S. was limited in range. And from Todd Veazey, we advance these critical ideas, the idea of norms, international norms and behaviors. And what he's also wondering is how much support you sense from this, from our participants here, from China and Russia. Where do they come into play from all of this? So it's kind of like, are they supporting this, and are they doing it, or are they doing this to their advantage? And what's kind of your sense of things? Let me leave that to you. You can fight over the answers there.
Yeah, I'm happy to start on that one. So basically, what is the position of Russia and China here? So they have, I believe, starting in about 2008, proposed a treaty. It would be a binding treaty. Originally, it was the Prevention of an Arms Race in Outer Space, or PAROS treaty. And then more recently, I think around 2014, they put forward the Prevention of Placement of Weapons in Outer Space treaty, the PPWT. Both of those proposals, which were joint between Russia and China, the U.S. said were fundamentally flawed from a U.S. perspective, essentially because of this issue of intent that you can't really tell, from the capability and from the developments, whether someone's actually abiding by this treaty. And then also with PPWT, in particular, a more recent one, it doesn't address direct ascent anti-satellite weapons, so weapons that would go directly from the Earth to space, which is the kind that we've seen, historically the U.S. and Russia have tested, but then China more recently and India. So one of the weapons that people are particularly concerned about doesn't fall under this treaty that's specifically meant to deal with space weapons. And so that effort has not gone very far. There was an effort led by the EU to develop a code of conduct where they got agreement on the EU side, and then they opened it up to the rest of the community and kind of rewrote it and created this international code of conduct, which again was supposed to be, how can we make space sustainable? What are some things we can agree upon? And that was getting pretty close to agreement, and then Russia kind of torpedoed that effort on somewhat of a procedural issue. So, they didn't necessarily come out and speak against it substantively, but they took some actions to make sure that was not moving forward. So that effort is completely done. There have been some non-binding agreements. So the transparency and confidence building measures that were developed within UN COPUOS, one of the UN committees on the peaceful uses of outer space. Those you can take a look at the text of them. I think it is a useful effort, but it is also relatively broad. And they haven't, they've gotten agreement on some of these long-term sustainability guidelines, but not all of the ones that they would have liked to see. So now there's this most recent effort that I mentioned, started by the UK, I believe last year, and ongoing now. And I have not seen yet how Russia and China are responding to that. So, and as you saw with the code of conduct, it's not clear. It's not always clear from the rhetoric and kind of the substantive response. So we'll sort of have to wait and see what they're going to do on that front.
Yeah, I would just say I believe everyone who works in space, who has assets in space, has an incentive to make space a secure domain and a managed domain. So, I feel like the confluence of interests is there. It's just a matter of creating the framework that everyone can agree to.
Yeah, so those are both great responses. I think the issue from the US perspective is that a lot of the past efforts have been to ban certain types of space systems, which I think is just a fundamentally flawed path. Space systems by design are inherently capable of a lot of different things. For instance, I can use a normal command and control antenna that I would use to send commands to my satellite. I could turn up the power and point it to something else, and it's a jammer. So if you're going to ban jammers, then you'd have to ban every antenna that can be used to communicate to satellites. A launch vehicle can inherently be used as a kinetic weapon. And then the US's demonstration of shooting down a satellite with the Navy Standard Missile 3 demonstrates that even things not inherently designed to be space weapons can be utilized in that way. So I think the flaw in these and the proposals of the past have been that they were designed to ban capabilities. What I think we need to focus on is regulations that govern action in space. So instead of saying you can't have, a satellite that can grapple, you say you cannot take your grappling satellite within, 100 meters of my satellite, or I will respond. So it's less about the capabilities being employed and more about how they're being employed, I think is the right approach moving forward. And I think to get to the question of whether or not that limits us, I think that actually makes us safer, because right now there's so much uncertainty in what constitutes aggressive action in space that I think there's a significant risk of miscalculation and inadvertent escalation. So if we set these standards for operations, we can still do all the same things that make our military extremely capable by relying on space-enabled capabilities, while reducing some of that uncertainty and risk of the actions of others. So I actually think it makes us better operators in space, because we reduce some of that misperception that could be out there.
Great. These are great responses, and want to kind of turn this into a little bit more on the technical side of things. And of course, I welcome all of you to contribute to this. The question, I'll start off and I'll combine a couple here. First, from again Todd Veazey on this one. Are we? Sorry, I lost the thread here. The question has to do with. Let me actually ask this one first. This is from this is an anonymous source. Achieving military space effects in space is high tech and expensive activity. Can you identify a few of the significant, relatively low tech and low expense vulnerabilities to space systems in the land, air, and sea? And I'll turn it over to you while I search for the other question.
Yeah, I guess I'll start. I'll just say that, first of all, there are a lot of services provided from space. In fact, many average citizens on the Earth don't even realize all of the services that come from space even today, and I think that will just be more so in the future. Not just things like imagery, although that's very important, but positioning, PNT. Mapping, things like water monitoring, crop monitoring, even in shipping, and also fishing industries, things like that. If these things were denied, it would affect those industries on the ground. I think there are ways that, in a worst case scenario, all these services could go away. So the most obvious is some kind of a jamming environment. Major Stewart mentioned that, where you basically have you lose the ability to receive those signals from the ground or on the ground. So I do think there are sort of low tech threats that could be sort of universally applied, and at least maybe in certain regions would deny access to those services, and that would be very harmful to the kind of quality of life of people in those regions.
So I can add just quickly on that topic, and I know someone else asked about, what are some of the threats and things we're seeing more generally. There are two organizations, the Center for Strategic and International Studies, CSIS, and also Secure World Foundation, that put out, either on an annual basis or close to it, unclassified reports on threats to space assets that are really pretty well put together. I actually think one of them was just released today, the Secure World one was, and CSIS really pretty recently as well. So I would also just point you to those if you're interested in reading more detail about, on the unclassified level, what are some of these specific threats.
And I'll just add on. So yeah, the military systems are exquisite. They're extremely expensive. They're very valuable. But there are efforts within the DoD to kind of create more resilient architectures by employing some of these small satellites for military uses, and kind of lowering the cost of some of these systems broadly. The idea being that if you've proliferated hundreds of satellites that do something that used to be done by 4 satellites, then it kind of reduces an adversary's incentive to attack those satellites, maybe by requiring them to attack 100 versus 5. And then from the other end, at the same time, though, threats to space systems are becoming cheaper. All space systems need the cyber domain to operate for command and control, for link segments. And so the ease of access through cyber is a lot more of an imminent threat to me than, for instance, like a direct descent ASAT. I don't see that being necessarily our most likely threat. It's more likely to be something in the cyber domain, which potentially has a lot higher number of actors who are capable in that realm as well. So while systems are becoming cheaper and more resilient, the threats are also becoming cheaper and more expansive as well.
Great. I'm going to turn. I'll come back to the other part. There was a question we had on the combination of artificial intelligence and satellite, but I want to turn to another one that kind of gets the mind going. The question has to do with what is the collision rate based on, and what does the math show? Basically, I think another interesting part of this is also when will space become so crowded that collisions will happen at an unacceptable rate, for example? Kind of what's that point or threshold we're working at that's not necessarily alarmist, but also realistic and to give some type of perspective on that?
Yeah, first of all, let me just say that the way space works, there are certain orbits that are much more popular and useful than others. So there's geostationary, of course, which is really great for satellites that want to be over a certain part of the Earth continuously, because the orbit rotation rate is the same as the orbit period, as the Earth rotation rate. There's also an orbit called sun synchronous, which basically the orbit plane maintains the same alignment with respect to the Earth-Sun line, and that is very useful for imagery and for power generation. It has a lot of applications. And of course, there are certain orbits like the International Space Station, which there's a lot of traffic in those orbits due to strategic assets there. So these orbits tend to be much more crowded than space in general. You hear that space is like, so big, right? What are the odds of 2 people on the surface of the Earth walking into each other? But certain orbits are actually more crowded because they're more useful. I think we have to think of these orbits as very special assets that have to be protected or have to be managed. When people retire a geostationary satellite, they should have the capability to deorbit out of that orbit, at least to another orbit nearby that is not as important. It's the relative motion that really leads to the problem of space being unusable and having collisions. If all the satellites in the same orbit have the same exact relative motion, you don't have as much of a problem. And it just becomes a density issue of how closely can you put all these spacecraft together without there being accidental collisions. So I don't have a hard number like, oh, the number is this. When we get to this many satellites, it will be unacceptably high. But I do think that what has to happen is we need to have certain particular orbits that have to be very more actively managed because they are sort of strategic orbits. And then, there need to be general guidelines, particularly on separation distances and relative velocities. So like I said, there should be rules of the road when you are so far away from a certain satellite, when you're within a kilometer of another satellite. Maybe it's 1 part in 1,000. Your relative velocity should not be greater than 1 meter per second. And once you exceed that, you're exceeding some space density guidelines that would lead to unacceptable risk.
Yeah, I would maybe add on. I mean, I think Dr. Lightsey is exactly right. It depends a little bit who you ask. There's not a specific number, but there certainly are some space operators who feel that we already are at a point that's unacceptable, right? That, the number of conjunction warnings that they're getting from Space Command, they feel is, untenable. So their operators are choosing not to maneuver, even though, they're getting this warning that they could potentially have a collision. And so I think, from that perspective, you have people who say, it's already, we're having too many close calls, and we have had at least one major accidental collision back in 2009, but some close calls that have been in the news recently as well. So, I mean, it's something that certainly is a problem. And I think if you look at the introduction of the mega constellations, then things really start to ramp up. And I mentioned that, the NASA Large Constellation study where they said, we really have to start changing the rules. Essentially, you can't leave those thousands of satellites up there for 25 years, which is the current agreement, without really running into this kind of problem. And there's a name, the Kessler effect is the term for this idea of, space getting so crowded that becomes unusable. But still not a specific number. There are people who think we're already at the beginning of it, and those who think it's really quite a way off.
Yeah, that's the idea behind the movie Gravity, right? Basically, as the satellites collide, it creates more debris, which creates more collisions, and it's like a chain effect. Whether that is actually would ever really happen or not is kind of a subject of debate. I think it's sort of an apocalyptic scenario. But I do agree. I mean, it has to be managed, right? I mean, otherwise it gets out of control.
Yeah, and so one of the issues is this question can't really be answered definitely because this is a continuous process. Every single launch generates new satellites, obviously, but there are also things like payload fairings and second stages and bolts and things that fall off of launch vehicles. And so each of those objects then propagates an entirely new set of possibilities. And so when you have a collision like Iridium and Cosmos that Dr. Borowitz mentioned, that creates thousands of pieces of debris, or ASAT tests that create thousands of pieces of debris, then all of those create an infinite number of new possibilities of collisions. And so we don't know when the next collision will be because it hasn't been determined yet. It will be somebody maneuvers, and then that changes all the calculus for all the satellites, and then a collision happens. All those pieces of debris then change the calculus. So it's a continuous monitoring process. And as Dr. Lightsey mentioned, there are some orbits that are extremely valuable. And so for those orbits specifically, it needs to be more than just US Space Command watching and providing warnings. It needs to be an international arrangement that kind of protects these highly valuable orbits that could then lead to debris clouds and fields that plague a number of other operators who weren't initially involved.
Well, great. Now we have less than two minutes. I have to use this lost in space question on AI had to do with if AI could be applied to enable autonomous repositioning for collision avoidance based on the universal telemetry database or other applications. And I want to give you kind of the choice on the remaining time, whoever wants to, because I actually saw another really important question, and I think it's really important for this group to address. As far as, is the United States doing enough to invest in this area? Because I know a number of you, and probably all of you, have a passion for this area. You talk to people that worked in space or even engineering, and they go to it because they love it, or you see the movies of people looking up to the stars. Do you think the United States is doing enough in this? What could be done more? This seems to be the ultimate question. It's part of our developing this national security innovation base in that way. And choose one or the other or both if you want to be quick. I talk fast, but go ahead. The floor is all of yours. Maybe
I guess I'll just address the AI question really quickly. I definitely think AI has a role to play in space, but AI is not enough by itself. It has to be enabled by information, and therefore there has to be sensing, there has to be situational awareness, there has to be communication, there has to be onboard processing. So we're not there yet, but I do think that's the kind of thing that could be in a 10-year or a 20-year plan. And there needs to be autonomous, I would say, collision avoidance. Like, it's not enough to wait for the spacecraft to be told what to do. It should be able to sense its own environment and react to that.
Yeah, I can add on, I think, already SpaceX with their mega constellation has said that they're going to have an AI capability to avoid collisions. But from a social scientist perspective, there's also a trust issue there. It's fine for them to do that, but they say their system is proprietary and they're not going to tell anyone else, when they're going to maneuver or how or any of that. So it's not clear that really solves a problem or makes these things safer for other operators. Yeah, so still problems even with the AI.
Yeah, another issue of AI, so I sort of alluded to it earlier, is you can use knowledge of a system's AI to figure out tactics. So I could close approach your satellite to make you, to trigger your AI specifically so I can see how it moves, and also let you burn some of your fuel moving around and reduce the lifespan of your satellites. So there, AI is a definitely viable solution, but there are also threats in that regard as well. And then just generally for the question of the United States doing enough, the United States has been a leader in space since the beginning. And I think we still are. I think if you asked anybody in the military if we'd want to trade our capabilities with any other nation, the answer would absolutely be no. We are definitely leaders in space, but that also comes with the responsibility that we need to lead solutions in space. And I don't know if we're doing enough in that regard. I don't know if we've invested enough in cooperation, not just with our closest allies, but also our competitors, which is really what's ultimately going to make space safer. So, I would offer that our cooperation needs to extend beyond our traditional partners, and it needs to go much deeper into those who we consider adversaries in space, or else we're really not going to make any, future sustainable operating environment for anybody.
Yeah, I would completely agree with Brian that, I think we're in a point right now where the technology is exceeding the policy and international relations. And so on that side of things, on the international agreements, on the policy side, we're not doing enough yet. So I think there are some movements to try to speed up there, but I think, in Brian's positive way of putting it forward, there's a lot of opportunity that we still need to take advantage of.
Yeah, and I would say the time is now. Like, we can't wait 10 years. The problem is just going to get worse. If you view it as a problem, I mean, the issue is increasing capability in space for everyone, which really is a good thing.
Hey, Dr. Rubin, it's Mariah. I just wanted to say, I'm gonna let the audience know that the panelists have agreed to stay on a little past the hour to answer some additional questions. So we have a little bit of breathing room here.
Okay, and for those who are leaving, thank you very much for your attendance. Thanks to SMA ahead of time and to our panelists so far. But we'll carry on. I can also go through the additional questions that we had here. There are others. Okay, so I'll go through some of the other questions that we didn't get a chance to go through here for those that might have left already. What types of concerns also are there around cybersecurity in that way? Is there something special about space cybersecurity as opposed to, if I can kind of jump onto this question a little bit more, space cybersecurity that we don't have in other domains in that way? Is there something that makes it special or unique?
So I would say that cybersecurity challenges in space are basically compounding an already significant challenge in space. So attribution in space is challenging enough as it is because there are things that can happen to satellites that appear to be nefarious, potentially, that are totally related to natural phenomenon. So you can have coronal mass ejections or solar events that send out charged particles that get inside spacecraft and cause reboots and anomalies and things like that. So that sort of stuff can appear to be hostile, but it could be totally related to something natural. So it's already challenging to attribute the source of something that happens in space. When you add cyber on top of that, you just further complicate that challenge. So cyber as a domain, cyber attacks are tough to attribute. When you apply them to like a link segment, which is how the space between an antenna and a satellite, or to a C2 node, it just compounds the challenge of attribution. So I think cyber challenges in space are most significant because of the challenge of attribution.
And I would say too that it's just an inherent challenge. It's something we can never get around for space assets, right? Just because of the nature of their remote location. And it's also something that we have already seen, so again, like a lot of the threats that we talked about today, it's not a theoretical situation. We know that China hacked into a US weather satellite, right? And didn't damage it or anything as far as we know, but definitely had control of it and had access to the information there. So and there are other examples as well. So we know that this is something that already has happened and is happening.
Yeah, and I'll just add on, I think their spacecraft are especially vulnerable because they travel over the entire Earth, and pretty much anyone with a line of sight can communicate with them, and therefore they can be hacked. And so that is one of the ways that those assets can be compromised or attacked. And so it absolutely is a big issue for all spacecraft.
Great. And a couple of other questions we have from Brian Meadows again. Wonder, will mega constellations, I guess the level of the LEO of sensors mean true persistent ISR? Brian, this would be right up your alley, right? Or anyone else's.
Yeah. So I guess Dr. Borowitz has some experience with this as well, but yeah, so there are already, there have been proposals in the past, both on the military and commercial side, to have more persistent ISR from not just LEO, but from other orbits as well. Obviously, LEO gives you higher resolution, but higher orbits give you longer staying time over an area. So yeah, I think that's what we're already seeing, is that SpaceX's constellation to provide persistent telecommunications coverage could also be used to have a robust ISR constellation, and some providers are already doing that with small sats. So yes, I think persistent ISR is one of the things that will come with mega constellations in the future.
Right. So I think, yeah, Brian really got it. With the original set of remote sensing, particularly on the commercial side, commercial companies, the focus was really on very high resolution imagery, right? Getting down to kind of 30 centimeter level. Whereas now in the kind of new wave of commercial remote sensing, like the company Planet, you're seeing them putting up instead hundreds of satellites, and what they're really focusing on is revisit time. So it might be more like a meter resolution in terms of the level of specificity that you can see on the ground, but you can see it once a day, or even once an hour. And there are companies that are talking about doing persistent video and things like that, and that's on the commercial side. So I think you'll certainly see that on the military side as well.
Great. And I think, if there are any closing thoughts or a number of other great questions, we want to be respectful of panelists' time and so forth. But any other closing thoughts? Maria, I don't want to take the opportunity from you away to close it out by any means, but any other final comments on any other things you wanted to add? No. Well, want to appreciate whoever's still in the audience, the attendance, and certainly our panelists, and all the great questions, and some of the ones we didn't necessarily get to. But and thanks again, and please be in touch with any of the panelists here, and stay tuned for hopefully more coming from my colleagues as well at Georgia Tech. We're very happy to have this type of collaboration and these efforts that go along in this both space technology aspects and space policy and on the national security front. Thank you very much. Thanks to SMA again for this opportunity, and to the audience.
And I'd like to add my final thanks to all of our panelists, Dr. Rubin for moderating and handling the questions today, Dr. Borowitz, Major Stewart, and Dr. Lightsey. Thank you for taking the time to participate. This was really great. I learned a lot. And thank you to our audience for joining in. I appreciate everyone, and have a good weekend. Thank you all.